Hello students, are you ready for another math lesson? Do you have your notebook and your pencil? Are you wearing your glasses? You know you should always wear glasses to math class. They help division. Get it? Sorry, you know, math puns are the first sign of madness, so I guess I'm losing it. Let's do Solving Trig Equations, Part 1, notes number 47. Okay, we're solving trig equations. This is a great way to pull together a whole bunch of different things we've been doing with trig and even things we've been doing with algebra. This is really where things come together. So for each problem, we're going to solve for exact answers over the interval from 0 to 2 pi. And that means that we can have as many answers as possible that range between 0 and 2 pi. Sometimes we'll have multiple answers, sometimes we'll only have one answer. So here's our first equation, 2 cosine theta equals 1. So let's divide both sides by 2, and we get cosine theta equals 1/2. Now this should remind you of the inverse trig problems we've been doing. We're looking for the angle whose cosine is 1/2. And if we take the inverse cosine of both sides of this equation, we get theta equals inverse cosine of 1/2. So you ask yourself, what is the angle with a cosine of 1/2? Well, when we were doing the inverse trig assignment, we were limited to just one answer. We were limited to just the quadrant 1 answer. However, because we're looking for all answers in our interval from 0 to 2 pi, you want to think about every quadrant where cosine is positive. Cosine is positive in quadrant 1, and cosine is positive in quadrant 4. So let's draw a reference triangle in quadrant 1 and a reference triangle in quadrant 4. And cosine is 1/2, so we'll put 1 on the adjacent and we'll put 2 on the hypotenuse. So what does that leave you for the opposite side? That one must be square root 3. So it looks like we have a 30, 60, 90 triangle with a 60-degree reference angle. Even though I didn't draw it to scale, we know that 60 is always across from square root 3. Okay, so one of our angles is 60 degrees and the other angle is 300. Now, we're not actually answering in degrees though, are we? We're answering in radians. But if you're like me, you think in degrees first and then you convert to radians. I'm sorry, that's a weakness of mine, but hopefully you'll forgive me. So if you think of it in degrees first, you have 60 degrees and 300 degrees. And then if you convert to radians, you get, what do you get, remember? 60 degrees is how many radians? Tell me. That's right, pi over 3. And what about 300? That would be 5 times 60, so 5 times pi over 3. That's right, 5 pi over 3. There we have equation number 1 solved. Let's move on to number 2. 3 sine theta plus 3 equals 0. Again, solving for answers over the interval from 0 to 2 pi. So let's start by subtracting 3 from both sides and divide both sides by 3. Now let's take the inverse sine of both sides, and theta is the inverse sine of -1. So you're thinking to yourself, I want the angle whose sine is -1, and I want all possible answers that fall between 0 and 2 pi. So where is sine equal to -1? We have to be on the unit circle for that. Sine is equal to -1 way down there at 270 degrees. 270 degrees is what in radians? Remember? Well, what's 90? That's right, 90 is pi over 2. This is 3 times 90, so it's, yep, that's right, 3 pi over 2. You got it. I'm glad you still know those. We need to just keep practicing. Okay, moving on to number 3. We're going to do 5 examples. Here's number 3, 1 minus cosine squared x equals 0. This one is super exciting because we are going to do it 3 ways. How excited are you about that? Okay, so method number 1. Do you recognize that we have a Pythagorean identity peeking at us? Do you remember this one? Sine squared x plus cosine squared x equals 1. And what would happen if we subtract cosine squared x from both sides? We get sine squared x equals 1 minus cosine squared x. So method number 1 would be to do this substitution, use an identity to do a substitution, and we get sine squared x equals 0. Now we're solving for x. Let's square root both sides, and the square root of 0 is just 0. Now let's take the inverse sine of both sides. So x is inverse sine of 0. The angle whose sine is 0. Let's see, that's another quadrantal one. Unit circle. We would be either at 0 degrees or at 180 degrees. Convert those to radians, and we have 0 radians or pi radians. Okay, method number 2. Instead of using a trig identity and doing a substitution, let's just solve this directly. So we're starting with 1 minus cosine squared x equals 0. Let's add cosine squared x to both sides and square root both sides. And don't forget, when you square root 1, you're going to get plus or minus 1. How come when we square rooted 0, we didn't get plus or minus 0? What's up with that? Okay, so this gives us two equations. This gives us cosine x equals 1 or cosine x equals negative 1. So that means x is the inverse cosine of 1, the angle whose cosine is 1, or x is the inverse cosine of negative 1, the angle whose cosine is negative 1. What angle has a cosine value of 1? Well, let's just use the unit circle that was already drawn. That angle is 0 degrees, also known as 0 radians. And what angle has a cosine value of negative 1? That angle is pi radians, 180 degrees, pi radians. So notice we get the same two answers, luckily, doing it a different way. If you do it a different way and you get a different answer, something's wrong. Okay, third method. You probably saw 1 minus cosine squared x, and probably what went through your mind was this. Ooh, that's a difference of squares. I know how to factor that, right? So let's say we factor 1 minus cosine squared x into 1 minus cosine x times 1 plus cosine x. Remember, we did some factoring in our last lesson, or one of the last lessons. I don't know. They're all blending together at this point. I guess it was a couple lessons ago. Let's set each of these equal to 0. 1 minus cosine x equals 0, or 1 plus cosine x equals 0. And then we're going to add cosine x to both sides. 1 equals cosine x. And take the inverse cosine. So x equals inverse cosine of 1. And then on the other one, subtract 1 from both sides. Cosine x equals negative 1. Take the inverse cosine of negative 1. Notice these are the same two equations that we just had in the previous method. So we're going to get the same two answers, 0 and pi. Now, there may be some equations that you solve that you have to use a trig substitution for, an identity to do a substitution. You might not have a choice to do a whole bunch of different methods like we did in this one. This was just a really, really special one. Number 4. Okay, we have something that's already factored. Remember in number 3, just a minute ago, when I showed you the third method and I factored both sides and then I set each factor equal to 0? Well, number 4 has already been started for us in a way because it's already factored. So we can set each of those equal to 0 and solve each one. So we have tangent x minus square root 3 equals 0, or 2 sine x minus 1 equals 0. So for the first one, we're going to add square root 3 to both sides, and then take the inverse tangent. X equals inverse tangent of square root 3. You can think of it as square root 3 over 1, because that way it'll be easier to picture the opposite and the adjacent. So let's see, let's draw a picture for that. It's a positive, so we must be in quadrant 1 or quadrant 3. And tangent is opposite over adjacent, so the opposite is square root 3 and the adjacent is 1. Or if we're in quadrant 3, we have negative square root 3 on the opposite and negative 1 on the adjacent. So what angle do we have there? What's our reference angle? That would be 60 degrees. So one of our answers is 60 degrees and the other answer is 240. But we need to convert those to radians. So we have pi over 3, and we have, what's 240, remember? 4 sets of 60, so 4 times pi over 3, so 4 pi over 3. Now the problem's half done. Don't forget we still have the other equation to finish. 2 sine x minus 1 equals 0. Add 1 to both sides. 2 sine x equals 1. Divide by 2. Sine x equals 1/2. And then take the inverse sine. X equals inverse sine of 1/2. The angle whose sine is 1/2. Let's picture that. Since 1/2 is positive, sine would be positive in quadrant 1 or quadrant 2. Sine is opposite over hypotenuse. So that's our 30, 60, 90 with what reference angle? That's right, 30 degrees. So we have a 30-degree angle and we have a 150-degree angle. Can you believe how these things that we've been doing for months are still valid and we're still using them? Remember all those exact values problems you did and all of the exact values quizzes you had? Now you know why. See, we still need to understand it. Okay, so our answers are 30 degrees and 150 degrees. And let's convert those into radians and we get pi over 6 and what's 150? 5 times 30, so 5 pi over 6. So this one has 4 answers. Okay, we have one more example. Number 5. I know what you're thinking. You're thinking, ooh, that looks like a quadratic in disguise. Remember those from the beginning of the year? Quadratics in disguise. That's my phrase. You're probably not going to see that in any book or hear it from anybody else. I don't know, maybe it'll catch on. Maybe you guys can help me set a trend or something. So a quadratic in disguise is something that looks quadratic, but isn't just, like 2x squared minus x minus 1. It's not that simple, but you could factor it the same way you would factor a quadratic. This reminds us of that lesson we had a couple of lessons ago where we were factoring. So this could factor into 2 times cosine theta and cosine theta for the firsts, and then 1 and 1 for the last. And then we would have to have a plus 1 and a minus 1 to get the signs to work out right for the inside and outside terms. So now that it's factored, we're just going to solve it like we did number 4, set each factor equal to 0 and solve each one. So 2 cosine theta plus 1 equals 0, or cosine theta minus 1 equals 0. Okay, let's do the first one. Subtract 1 from both sides. Divide by 2. Take the inverse cosine. And now think about where that is. Where is cosine negative? Cosine's negative in quadrant 2 and quadrant 3. Cosine would be adjacent over hypotenuse, so the square root 3 would be on the opposite. So now we know our reference angle is 60. So our answers are 120 and 240. Let's convert those into radians. And we have 2 pi over 3 and 4 pi over 3. And now let's solve the second equation. So we're going to add 1 to both sides. Cosine theta equals 1. Take the inverse cosine of both sides. And then ask yourself, where is cosine equal to 1? That would be on the unit circle right there at 0 degrees. So that would be 0 radians. So we have 3 answers. 2 pi over 3, 4 pi over 3, and 0. Okie dokie, artichokes. Here's your assignment. There's a worksheet. It has 7 problems. Number 1 is like example 1. Number 2 is like example 2. Guess what number 3 is like? And 4 and 5. That's right. They match up. So you could look back at your examples as a guide. And then there are numbers 6 and 7, which you're going to figure out. You can do it. I think you don't need an example for those. I think that you can use your little brains and figure it out. Check your answers, ask questions, send pictures, and have a great time.